Learning about special parallelograms. We are learning 3 new shapes: rectangles, rhombuses, and squares. Okay? So, a rectangle by definition is already a parallelogram with 4 right angles. How many right angles? 4. Okay? A rhombus is a parallelogram with 4 congruent sides. How many congruent sides? Now, do you know anything about a rhombus's angles? No. Do you know anything about a rectangle's sides? No. Okay? Now, a square is both of them. It has 4 congruent sides and 4 right angles. So a square is both a rectangle and a rhombus. Okay? Squares are regular quadrilaterals. Very good. Now, I would like you to associate a picture with each of these definitions. For a rectangle, make sure that you stress the fact that one set of sides does not need to be the same length as the other side. Are we familiar with a rectangle shape?
Yes.
Excellent. Now, a rectangle is a parallelogram still. Do you guys agree? Yes. Opposite sides are parallel. Opposite sides in a parallelogram are also congruent. Do you guys remember that? So although 2 of the sides are congruent to each other, right? The 2 sides on the top and the bottom, up here and down here, are congruent to the sides on the left and the right. Not all 4 of the sides are congruent to each other. Do you guys agree with that? There's no way that longer side is going to be congruent to the smaller one. Hayden? No. A rhombus is a parallelogram with 4 congruent sides. 9 times out of 10, guys, your rhombus is going to look something like this. And it's going to have congruence marks donde? Where are its congruence marks? On the sides. And they're all the same congruence mark. We Gucci?
Yeah.
Now, a square is a regular what? Not parallelogram. A regular quadrilateral. Because it is equiangular. All of the angles are what? All of the angles are what? Specifically?
Congruent.
All the angles are what?
Same.
Yeah, but specifically, how many degrees? 90. Okay? And all of the sides are congruent. Right? So we're going to draw a little square. Oops, that's not a square. It's as good as it gets, peeps. 4 90s. 4 perpendicular angles, and 4 congruent sides.
So it's like a 2-in-1.
It's like a 2-in-1, okay? Yeah. If we were to compare this, the square is like, have you guys seen Mean Girls?
Yes.
Where they're like, you can't sit with us? Yes. The square is the most exclusive. You can't sit with them unless you are both a rectangle, you wear pink on Wednesdays, and you are also a rhombus, okay? Yes. All right, so moving on. Guys, these 3 definitions are called their corollaries, okay? So the rhombus corollary says a quadrilateral is a rhombus only if and only if it has 4 congruent sides. A quadrilateral is a rectangle if and only if it has 4 right angles. And a square is a quadrilateral that is both a rhombus and a rectangle, okay? There are also shapes and diagrams to show you what they're talking about. Any questions on this slide? So the only thing that you guys need to know is that when you're talking about the rectangle, the rhombus, or the square, its definition, reference it as the corollary, okay? All right, big enough to say a theorem after it, right? So it's like a step less than a theorem, basically, okay? What?
What does that mean again?
Corollary is just like, it's like an assumption that we make about geometric theorems, right? So that was like not. Now, in your Venn diagram, you should be missing words, okay? Remember, the most basic term for a figure that has 2 pairs of parallel sides is a parallelogram, okay? That's like the most basic shape that we've talked about. Then you get more specific when you talk about rhombuses. All 4 of their sides have to be congruent. And you're also talking about rectangles when you have 4 right angles. So those are more specific types of parallelograms. Do you guys agree? And the most specific that you see the least of is what? Squares. Because it has to be both a rhombus and a rectangle, okay? So in a Venn diagram, that would be the only shape that satisfies all three. It's a parallelogram, it's a rectangle, and it's a rhombus. Any questions so far? Okay. Now, remember, all three of those shapes are still parallelograms. Do you guys agree? So all of the properties that apply to parallelograms apply to those three shapes: rectangles, rhombuses, and squares. There's three additional properties that we now have to know. The first one is the rhombus diagonals theorem. It says a parallelogram is a rhombus if and only if its diagonals are perpendicular. That means not only are they going to bisect each other, because it is a parallelogram, they're also going to form what? A 90-degree angle, okay? So look over at the figure. Do you see how those two diagonals cut each other at a 90-degree angle? Circle the symbol that indicates that they're perpendicular, okay? That's the big takeaway from that first theorem. And that was for what shape?
Rhombus.
Rhombus. Does it do this for a rectangle?
No.
Does it do it for a square?
No.
Yes. Why does it do it for a square? Aren't squares rhombuses?
Yes.
Keep that in mind, okay? Now, the rhombus opposite angles theorem says that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. That means that the angles are being cut in half. They should be congruent on both sides. Let's go ahead and fill out our diagram with some imaginary numbers that I'm just going to make up in my head. Let's say this angle was 30 degrees. Do you guys agree that the angle on the other side of the diagonal would also have to be what?
30 degrees.
30 degrees, okay? And let's just imagine that these two angles would have to be the same. Let's say it was 40 degrees. What would the other one have to be? 40 degrees. Now, don't quote me on this, okay? Because these are not going to add up to 180 when you add them together, okay? But you guys understand the concept, right? Of the two angles next to each other have to be the same because they're being cut by a diagonal that bisects them. Actually, let me not do that. I'm going to give you legit numbers. So erase those. Sorry. Make these two down here 30 degrees each. And then we'll make, actually, does anyone know what the other two would have to be? 60. Very good.
What are we adding to?
So just change the numbers because then this angle is then 120 degrees in total. And this angle down here is 60 degrees in total. Remember, they're still parallelograms, so the angles that are next to each other have to be supplementary. So they have to add up to 180. All right. Last but not least, the rectangle diagonals theorem. The rectangle diagonals theorem says a parallelogram is a rectangle if and only if its diagonals are congruent. That does not just mean, before in parallelograms, we knew that the diagonals bisected each other, correct? But now we know that diagonals in a rectangle are the exact same length. So all four of those pieces of the diagonals, once they intersect each other, are going to be the same length, okay? Now, put a little star at the very bottom of this slide. All three of these theorems apply to squares. Why? Nick? Very good. A square contains both congruent angles and congruent sides. It's both a rhombus and a rectangle. Okay? Any questions on these theorems? Carson?
So what, like square opposite angles theorem, square diagonals theorem?
No. If you're given a square, you'd still say by the rhombus diagonals theorem, the diagonals are perpendicular because squares are rhombuses, right? So it's just anytime you have a square, think any theorem that we've learned about any parallelogram, rhombus, or rectangle can apply to that square. Okay? Yes?
You mean square? You mean like just any shape that has four sides?
No. Squares are not any shape that have four sides. What's so special about a square? Quadrilateral, but that's the most basic term. Yeah, what else do we know about squares? Yeah.
They have congruent sides
congruent sides and angles. It's the most exclusive. Like I'm telling you, like this, squares are like VIP. They show up to the club and they're just let in, okay? Because they are so exclusive, you will not see them very often, okay? Any other questions about squares, rectangles, or rhombuses? That's all the learning we got today, okay? The rest of it is examples, application. We ready? On your marks, get that first theorem that we just learned, the diagonals theorem, the rhombus diagonals theorem. No, sorry, opposite angles theorem, excuse me, okay? It says that opposite angles in a rhombus. What does the rhombus diagonals theorem says? The diagonals of a rhombus are perpendicular. Let's do this. Example 1. Quadrilateral ABCD is a? Circle it. That's the most important part of this entire word problem is that it told you it was a rhombus. So all my rhombus rules apply. Do you guys agree? Do my rectangle rules apply? No. Okay. Find the measure of each angle. ACD. Start at A, go to C, go to D. Do you guys agree it's this angle right here? What does it have to be, Hannah? Oh, you're going to ask a question? Hold your question. Yeah, Daniel.
62.
It's 62 degrees. Why?
Because all the triangles are the same. All triangles are congruent. So
No.
it's
Oh, not all those triangles are congruent. Not all those triangles are congruent. Yeah, John.
It has an angle bisect, so it's like cutting it in between.
It does have an angle bisector. That is the definition of the bisectors of a rhombus. Do you guys remember that? It was just bisected by the diagonal. So this side has to be 62. These two up here also have to be 62 degrees and 62 degrees. Hannah, what was your question?
This question's kind of silly probably, but all squares are rhombuses, but not all rhombuses are squares.
Correct. Did you guys hear that question? All squares are rhombuses, but not all rhombuses are squares. Is this shape a rhombus? Because it told us. Is it a square? No. Do you guys see the difference? Because in order for this to be a square, what would need to happen? 4 right angles. And we already know it's not 90. Do you guys agree? Moving on. Angle DEC. DEC. What is that angle? What? It's not 59. Daniel? It's 90. Why is it 90?
It's a right angle.
How? Why is it a right angle? We need to know why.
That theorem.
What? Oh, that theorem. What's theorem?
The diagonals theorem?
The diagonals, the rhombus diagonals theorem. Look there. So these two are intersecting at 90 degrees. Okay? That means all of these angles are what? They're all 90. Okay? And then the next angle it wants us to find is EDC. EDC. 1, 2, 3. 3 congruence marks. What do you think EDC would have to be? 28 is correct. Hayden, how did you get 28 degrees?
I added 90 and 62 and then I marked it all.
Isn't this a triangle, guys? How many degrees are in a triangle? 180. So if you take 180 and you subtract 90, you get 90. If you take 90 and you subtract 62, what do you get? 28 degrees. Okay, so that angle must be 28 degrees. And our last angle, ABC.
28.
Not quite 28.
Isn't it the
I would say both of these are going to be 28, right? You're going to do what with the 28s? You add them together, and you get 56 degrees. Okay? Remember, bless you. On the opposite side, right, it's 2 angles added together because they're bisected by the diagonal. God bless you. So ABC is going to be 28 degrees plus another 28. So it'd be a total of 56 degrees. Is there another way you could have figured out that angle?
You could,
Very good. You could have added these two and gotten 124 and subtracted that from 180. And that would give you the measure of this entire angle, right? Because angles that are next to each other in any parallelogram are supplementary. They add up to 180, okay? There are sometimes even 3 ways to solve these kinds of problems just because there's so much symmetry and so much congruency when we're talking about parallelograms, okay? All right, any questions on any of these 4? Okay, 2. Quadrilateral MNOP is a?
Rectangle.
Circle it. The measure of angle PON. Oh, guys, by the way, O is supposed to be over here. N is supposed to be over there. Did it not copy over for you guys as well? Sorry about that. Something happens whenever I print these from PowerPoint. PON. Start at P, go to O, go to N. What is the measure of that angle? Why? Why is it 90? It's a what? How do you know it's a right angle? It's a rectangle. All of the angles inside of a rectangle are 90. So this guy has to be 90 degrees. Very good. What about PMO?
90.
Not 90. PMO is this guy, people. Start at P, go to M, go to O. It's not 29.
45.
It's not 45. It's 90 minus 29. 61 degrees. People, this is what shape? Why are the angles not bisected by the diagonals? Because that only happens for what shape? Rhombuses and squares, okay? This is a rectangle. So we do know that each angle is going to be 90, but we don't know that it's cut in half, okay? It actually is not in this scenario. It's going to be 61 and 29. So this angle must be 61 degrees. What would be the measure of PL? 12, because it's cut in half, so it would be 12. What would be the measure of MO? Nick? No. MO is a segment. It should be a length. No degrees. No degrees for MO. MO is looking for from here to here, how long is this segment? Mario?
24.
What? 24 is correct. How did you get that, Mario? Good, because this diagonal has to be the same length, guys, for a rectangle. So it must be 12 plus 12, which gives me 24. Now, example 3. Quadrilateral MORE is a? Oh, we got our favorite, the most exclusive. The most things that happen are in squares, okay? We have every single theorem that we've learned about applies here. ME equals 7x minus 3 and MO equals 6x. Find what x needs to be equal to. 7x minus 3 goes here. MO is 6x. What do I know about these two? Y. It's a square. What do we know about squares? All the sides are the same length. So I'm cool putting congruence marks on every single side, correct? So then these two sides must be equal, right? So what do I do to solve for x? All right, so what do I write?
7x minus 3
Equals 6x. Okay, someone walk me through solving it. Diana, go for it.
7x minus 3 equals 6x. Subtract 7x to both sides. It'll be negative 3 equals negative x. You cancel out negatives and x equals 3.
Yep, divide by -1, divide by -1, 3 equals x. Very good, Diana. Give it up for Diana.
Oh, yeah.
Woo! Okay. X equals 3 is the right answer. Now, in B, are we just solving for x? No. Underline the fact it wants us to find OE. Now, it gave us, let's see what it gave us. It gave us 4x for MT, so let's put 4x here. And we also know that it's TE, which is 3x plus 2. What do we do with these two? Because they're not part of the same diagonal. They're still equal to each other. Does anyone know why? It's a square, so it's also what shape by default? A rhombus and a? Rectangle. Remember, part of a rectangle says that all four, of these pieces of the diagonals are all congruent to each other. So even though it gave me two that are parts of different diagonals, I can still set them equal to each other because it is a square. Satisfies every single theorem, okay? So I would set this up by saying 4x equals 3x plus 2. I need a volunteer. Go ahead, Cody. Uh-huh. X equals 2. Cody, am I done? Can you help me? Okay, so we're going to do mt is equal to 4x. We're going to take this 2, plug it in. mt equals what? 8. What was it asking us for, though? OE. It's going to be double whatever mt is, right? So OE will be 2 times mt. So it's going to be OE equals 16. That's our answer. Take a look. Ask me if it doesn't make sense. Any questions? Do we understand why it's double? Can someone explain it again? Why did I double it at the very end?
Because you only had one part.
You only had one part. It was asking me for the full diagonal. All right, moving on. Example 4. What kind of shape is a parallelogram with one right angle? Yep. No.
No?
Mm-mm. Well, let's see. So, do you agree we have to start with one right angle, correct? Draw a right angle.
A diamond.
No? Did it say it could have more than one right angle?
No, it doesn't say that.
It has to only have one? Or could it have more than one?
It could have more than one.
Could have more than one, right? So what if there's one right angle though, what do we know about parallelograms? And their angles. Opposite angles are congruent. So do you guys agree opposite this figure I also need a right angle?
Yeah.
What else do we know about parallelograms and their angles? Yeah? Okay, so if this one's 90, what would this one down here have to be? 90. So do you guys agree we get a shape that looks like this? It's not a square. It's a rectangle. Why does it have to be a rectangle?
Because it doesn't say that it all looks like
It could be a square though, right? But does it have to be a square? No, because parallelograms only need opposite sides to be congruent, not all of them, okay? Yeah, it probably should say at least one, right? But my idea was to just get you guys to think like, remember, there are properties to parallelograms that we can apply to these problems. Remember, parallelograms have opposite angles that are congruent. Also, angles that are next to each other must be supplementary. Okay, on the next slide, classify the special quadrilateral and explain your reasoning. How many people think this is a parallelogram? It is a parallelogram. Why is this one a parallelogram? Yeah. It has four congruent sides, but that makes it more specific.
It has
Two pairs of parallel sides, okay? But most specifically, what is it? It's a rhombus. Are all rhombuses parallelograms? Yes, okay? So if it's a rhombus, there's no way for it not to be a parallelogram, okay? Is it a square?
No,
Why not?
because the right angles are not equal to each other.
Well, this angle's 60, right?
Well, yeah, but not
So right off the bat, is 60 equal to 90? No. So, why am I saying 60? It's 70. You guys are right. Is 70 equal to 90? No, so we automatically know it's not a rectangle. So what would be our explain, though? How would we explain that this is a rhombus? More so, what makes a rhombus a rhombus? Four congruent sides. Okay? It can't be a rectangle or a square because not all of the angles are 90. Okay. Always, sometimes, or never true. Cross out the last one. We have not talked about a trapezoid yet. A rectangle is a rhombus. It's not never. Sometimes. Why is it sometimes? What shape is both a rectangle and a rhombus? Just put a square, okay? If you are a square, you are both a rectangle and a rhombus. But if you're not a square and you're a rectangle, you don't have to be a rhombus. What about a square as a rectangle? This one's always. Do you guys see the difference? A square has to be a rectangle. You cannot be a square without being a rectangle. It's part of its definition. Okay? And the last one, example 7. This is a coordinate problem, okay? So we're going to decide whether, what does that symbol mean? Parallelogram. That's very important for this problem, okay? We're going to decide whether the parallelogram ABCD, after we graph it, is either a rectangle, a rhombus, or a square. And we're going to give all the names that apply. So let's go ahead and let's plot the points. -2, 6, 6, 8, 4, 0, and -4, -2. This was A, which was -2, 6. B, which was 6, 8. C, which was 4, 0. And then D, which was, -4, -2. Okay. Let's start. Is this a rectangle? Why not? No 90-degree angles. And if you wanted to be like very specific, guys, how could you find out if these two lines are perpendicular to each other? Use their slope, right? So let's go ahead and calculate the slope just to be very, very specific. Go down 1, 2, 3, 4, 5, 6, 7, 8. So -8 units. And to the left 2, so -2. Do you guys agree this slope of BC is going to be -8 over -2? What is that simplified? It's 4, right? Now the slope, let's take a side that's next to it, of CD, we're going down 2, so -2. And then to the left, 1, 2, 3, 4, 5, 6, 7, 8, -8. That slope is -2 over -8, which is +1/4. Are these opposite reciprocals of one another?
Yes. No.
They're not. Why not?
The 1/4 or the 4 would need to be negative.
One of them would need to be negative. Do you guys remember that? Okay. So I'm totally okay just by eyeballing this. If you're like, absolutely not, these cannot be a rectangle, you don't have to prove it to me, okay? And if it's not a rectangle, it's also not what else? A square. So we can eliminate those two. But what could it possibly be? A rhombus. Now let's think about how we could prove whether this is a rhombus or not. How can you prove whether this is a rhombus or not? If the sides are congruent. We already knew it was what shape from the beginning? Parallelogram. So we know that opposite sides are congruent. So I should pick two sides that are next to each other, and if they're congruent, do you guys agree this would have to be a rhombus? All right, so pick any two sides that are next to each other. Pick any two sides that are next to each other. John? Do me the honors?
Yeah.
You don't know? Yeah, Hannah?
AD and DC.
AD and DC. Very good. So in order to find out how long AD and DC are, what do we have to use?
The slope?
No, not the slope. That won't give us how long it is, yeah? The distance formula. So your BFF shows up again. Okay, let's do AD first. And those of you that moan every time I say the distance formula, you are not having a growth mindset. You can get better at it as long as you practice, okay? It's doable. But every time if you hear the distance formula, you groan and you sigh, it's only gonna be a struggle for you. You have to change your mindset. Be like, you know what? I'm gonna use this as a challenge. I'm gonna get better. I'm gonna pay attention. I'm gonna get this one. I'm gonna get it this time, okay? Just that slight change in your mindset can help you dramatically, okay? Does anyone remember the distance formula?
Negative
Square root, okay?
It's then
X
minus x2
2 minus x1 squared plus y2 minus y1 squared. No, it's not over 2. That's the midpoint formula. Okay, so let's plug it in. AD is going to be, we'll make A x1, y1, and we'll make D x2, y2. x1, y1, x2, y2. All right, so that means x2 is going to be negative 4. So we're going to take negative 4. We're going to subtract negative 2. So we're actually going to add 2, and we're going to square it. Then we're going to take y2, which is negative 2. We're going to subtract y1, which is positive 6. So negative 2 minus 6, and we're going to square it. Bless you. So AD is going to be the square root. Negative 2 plus 4 is going to give me negative 2. We're going to square it. And we're going to get negative 2 minus 6, which is negative 8, and we're going to square it. What is negative 2 squared? So it's the square root of 4 plus, what about negative 8 squared? 64, yes. What's 4 plus 64? AD equals the square root of 68. Do you know what the square root of 68 is? I don't either. Just leave it. Okay? Just leave it. Don't even simplify it. Okay? Because all we need to prove that the other side is going to be what? The square root of 68. So check it out. Let's do DC. So DC, I'm going to keep x2 and y2 for DC as D, but I'm going to make C now my x1 and my y1, okay? So let's set it up. It would be the square root of negative 4, minus 4 squared plus y2, which is negative 2 minus 0 squared. DC is going to give me the square root of negative 8 squared plus negative 2 squared. DC is going to be equal to the square root of 64 plus 4. DC is going to be equal to the square root of 68. Do they match?
Yes.
That means that all of the sides of this figure are congruent. Do you guys agree? Because if the two that are next to each other are congruent, it's also a parallelogram, so all opposite sides must be congruent. Therefore, it's what shape? Rhombus. All right, that is it for today's lesson. So I'm going to leave this up here. You guys can copy it down. Turn these in when you're finished.